I'm going to kick it off. We have 3 talks. This one is about what I learned about, from Github Copilot to AI native development. It's a talk that I've given already a few times. It will be a quick talk, hopefully. I'm still on a jet lag. I'm from Belgium. I just flew all the way in, so it's probably past midnight right now for me. So, I'll get it over with. Who am I? My name is Patrick Debois. Some of you might know me from the word DevOps. It was also something that I started with 60 people in a room in 2009 in Belgium, and this led to the movement of DevOps as we know it. I'm not saying this will happen here the same, but hey, amazing things can happen just from a meetup and getting the right people. Co-author on the DevOps Handbook. I try to be industry neutral, not like work for a specific vendor. That's why I like this community. I can talk whatever tool, whatever I like. I used to be, obviously, DevSecOps, and for 2 years, I've been very focused on GenAI. GenAI in the product, and more and more recently, doing engineering work with AI. So that's also what led to this event as well. I'm trying to make sense of this world, and as we go through the presentation, I have a few blocks. One of it is that we're seeing these tools doing coding for us, which I call delegated coding. We're moving away from the nitty-gritty specifying the exact code that we want to do and moving up to more specifications. We hope that the system works so well that we can delegate the trust, but it has to earn our trust first. And we're feeding it way more data. That's our code base, that's our Slack or Zoom meetings. Like, obviously, what I learned now in 2 years of dealing with AI, if there's a problem, we probably solve it with more AI. So there's a flywheel of kind of like believing that eventually we'll solve this into a good way. And last is that we actually keep that human oversight, because we don't want to have the machines run away without us being able to do. And when things fail, we still have to be able to deal with things that happen. So the first part, we all seen GitHub, tap, go, auto-completion on steroids, right? That's where it all started. That's probably what's been sold the most into enterprises. Copilot, yay, we got like tick in the box and we're there. I think obviously that it doesn't stop there. Yes, we got chat, but everybody has chat now in their windows, right? Like copy and paste, and this used to be very clunky. Hey, ask ChatGPT, copy and paste it in. Now we get way better. We get things like instant apply. This is from Cursor. Like, it was generated, we say apply this to the code, which is already a step up of us not having to copy and paste. It can even start predicting when we do a change, where's the next place our cursor needs to be. So the tab is not just a completion, but it's like jumping around in the editor where we think the next edit should happen. So it's already a step up from that auto-completion as well. Like, instead of just only auto-completion, we now have reasoning models added to the mix. So it's thinking things through. It's making a plan of attack on how to do things. It's not anymore simple code completion in there. Then, initially we thought, oh, you're stealing from our code. And then there was a whole discussion at GitHub, like, who copied what from whom. Ironically enough, the big companies were all complaining, like, you can't index our stuff. But guess what? Biggest companies were all asking, well, can you please train things how we do things? And eventually we got into more local code-based indexing because fine-tuning was too hard. And that was kind of like a middle ground that was really, useful to do things. Instead of generating a code snippet, changing one files, we got to multiple files editing. It was really, a game changer, not having to do kind of the different things step by step, but all of a sudden, and then we start a new kind of set of problems that we needed to review so many of the generated code all the time. We learned that we could add context, not just from our code, but it could read the terminal. So whatever error is on the terminal, we can feed it back to the code generation in the chat. That was another step up. And the same thing is happening with the browser. Like you can read the browser errors, you can read like whatever is happening. So it becomes eventually one big feedback loop of systems. Yes, of course, we want to generate tests because we were really bad at generating tests, but tests are awesome and will help us in the future. Guess what? Actually, AI is very useful to write tests because it always wants to change things. And if you don't have tests, we don't know what it has changed too much. So more and more, it was not about just the code generation, but it was also about the test generation and helping that improve. I mentioned the continuous loop. Devin, it will come up today a few times. It was a big spark. It will take your job away, blah, blah, blah. It's not that important. The fact is that there were maybe the first ones who articulated a little bit at that feedback loop that I just described in one tool where you can kind of get everything going and combine together. And then if you could take it like one step further, why have one agent? Why not have multiple agents working on the same code base? Again, I don't see many people do that today, but there's some truth to that maybe we're able to do this in a parallel universe when the tools actually get better. Wanted to bring this out. We've focused a lot of code generation, agents doing stuff, but here's an example of something that takes your code, put it into production, and actually auto-optimizes the code based on production feedback. Right, so this is like an A/B testing tool. So we're extending the loop, not just in our inner dev loop, to things that come from production. So this was all about code generation as such. Now the next kind of step up is the code-centric to specification. If you use Composer in Cursor, you start getting into that continuous loop of prompting. You don't write the code anymore. If you don't like it, you say a follow-up prompt, and you type less and less about the code. You just steer it into the direction that you want this. We've seen simple examples of people providing a markdown file in their coding, and they say, at specification, MD, do these things. So we're kind of reusing the intent of what we want and not just in the prompting, but we save this as almost like a specification in there. So we're getting towards what GitHub called towards intent-based coding. So it's not about the ghost text, it's not about the chat, it's about kind of like having a spec that gets coded according to a plan that we end up for. I'll skip this. Then we also have coding identities, where you can say, I'm a Python developer, I like these rules. I am a React, I have these rules. So part of this goes into the specification on how you want things done. You can add these rules now to your project. For this project, I want these rules. For that project, I want that rules. So people can reuse this almost like reusable prompts, reusable specifications in your projects already. And we haven't talked about design, because you can also upload an image and say, implement the UI, the front end, according to this image. So it's another way of specifying things, not in text, not in a prompt, but by providing an image. And then you breaks down into a whole plan. And I don't know what happened there, but you start seeing new tooling come around that actually start thinking like, why don't we just manage product requirements documents? And then coding will eventually come from that. We're not there yet technology-wise, but if you break this down into like smaller pieces of requirements, that is definitely something that we can do today. And so you get into that more specification-centric instead of code-centric working as a developer. And then the interesting thing will become when I change the specification, my code will change. I change my code, the specification will change. So that bidirectional kind of spec to code, code to spec will be an interesting way of doing this. So this is where the Copilots and others, Amazons, they're all thinking towards this direction that you're starting to specify this instead of having to do the detailed coding. Now, this was specification. The next thing I want to show is that we're having an explosion of context that we added. The whole workspace cannot be added. It's not one file that gets indexed. Here's an example of adding an external code library just as context to be reused in your own code. Very simple to add. Then we started adding documentation sources because documentation is awesome, so why don't we reuse that, right? Why would we trust the LLMs to kind of make up the things when we have the most current version of documentation available and we can point to that of what we're doing? So we start having more of these. So context is context aware, and we're just going to see this more and more explode in our tooling. We even start optimizing documentation to become usable as context. So much like SEO is like optimizing a website, our documentation will be optimized for being added as a context to the systems. And then we can bring in open telemetry information as more context of what is happening in production. Should I touch this kind of function? Oh no, it's being used like 1 million times the last couple of days. You should probably take care of this, right? Like that kind of context is going to be super useful to this. And then if you think about more and more of this context being generated, this is a nice example of Devon, whether it works or not, is you start feeding it more documentation, more context, and all of a sudden it says, I think this is important. Let me save this as knowledge, because then I can reuse this. You benefit from keeping this as knowledge described, and I benefit as an AI to use this for my next generation. So kind of that moves from documentation, more context, to knowledge. And then you can keep a memory, like first I did this, then I did that. So you kind of keep track of the specification. This tends to work better than feeding it a big specification that you have like small steps of incremental buildup of your specification there as well. Now, when we have a lot of information, we have that knowledge. Why don't we have the agents also use this to respond to pull requests? Because now we generate the code, we send the pull request. Now the agent can use all the context we feed it to actually reply to people who are having questions about this. So there's an auto-engage function that we can use there. Now, next part is, we got the context, we got the specs, we got the code gen. How is it going to win our trust? AI is still and will be an AI slot machine. Like we can't actually control always that good at what it generates. But we start working around this in many ways. Right? So if you generate code, like first you can check maybe the linter is working. That's great. That's good feedback. But will it actually run? Right? So you start seeing systems that actually take your code behind the scenes, they start running it, see if it actually compiles and runs. So that kind of shadow way of working of your editor has a shadow environment that it works with as a runnability check in there. And when it changes something, it will verify also whether it maybe like did something to the documentations that's now outdated. So it's giving us feedback of what it did, what the impact was. So that's how it's starting to gain our trust in a way that it makes us aware of what the thing that it was doing. We can even think about like the code that was generated. Like you could argue what good and bad code is, but for example, we could trace how complex the code is. Can a human still understand the code? Like we don't want like long files, so we can keep a check on this. We can kind of put these as quality metrics. So that kind of gains us trust if it feeds, if it passes these tests, that it's actually a better coding being generated. Obviously, we can go into security testing with threat modeling. Probably later, some verified refactoring we could do, whether whatever we're changing has the intended behavior, and that we could prove it. And then it started becoming interesting. Imagine it's gaining our trust. When do you think you trust the agent to auto commit? Right? Ada was one of the first to put this as a feature. I don't know. I think it's like the ratio is some heuristic. Like I feel safe enough that I can auto commit, but you can always revert if you wanted to. So that's interesting because that's a first level of trust that we're adding. All of these systems are adding checkpoints, roll back, do something, roll back. That is obviously one way of having a fail-safe environment for us to work in and allowing you to try things and see the impact of things in there as well. Another one, that I think it was Windsurf, had a feature called log file. So it says like, whatever you do AI, you cannot touch this. It's almost like an access control system for this is what we allow the AI to do. This is what we're not allowing to do. This is what a commit that we allow automatically. This is not. So this brings us to the human oversight because, hey, it's gaining our trust. But yeah, when things really fail, things will get fun in production, right? What's interesting is that we've been talking about cognitive load for a long time now. And I found this like an interesting way of dealing things. Left is the diff view, red and green. Hey, I'm colorblind, so it's like not that great for me. There's the chat view, which is basically explaining the change it did, but it's quite elaborate, and I don't have the time to read like everything through that it does. On the right, we see something like a condensed view, where it used natural language to condense a certain piece of the code that it just explains what the code did. So I just have to read those few lines. I don't have to dig into the whole code thing. So it's reducing cognitive load for me to be able to review the code faster. So that's like something that will need more and more as the more and more we're generating code of this. I touched upon the multiple files. The review thing is like, first review this, then do that, then go to the next. That kind of task-oriented breakdown is important because we cannot crock everything of all the files all the time. So it's giving us a focused way of reviewing things. We might get a fail-safe, as I said, multiple versions, choices. We can give it feedback, whether we liked it, yes or no, what it generated. Obviously, we want instant feedback and not having to wait like this awesome video. But that real-time aspect is getting more and more important, but the more we're waiting on the agent, the further away we get from instant having feedback from the results. This is an example of another way of dealing with the feedback. This is visualizing and making an image out of what was generated, but more as a diagram, not as a text. And it helps us way faster to understand what was happening instead of having to read this like S3 bucket got like this and that. So this is useful. So what we're saying is that the more maybe the text editor, which was very good, the code editor, now becomes more something as a domain-specific browser where we're dealing with a specific problem, with specific task for reviewing. So the editors become more like what they call moldable, in a way that people can extend this in getting easier reduction of cognitive load. So this was kind of like my summary of the different pieces that I saw happening in the mix in different tools and various pieces. This was not a tool-centric kind of presentation where I say, hey, tool A is better than B. But it gives you more of a guidance to say, hey, these pieces are important. This is what I'm looking for in kind of various tools to get better. And I know it's maybe a little bit too early as we're still in transition, but I summarized it as we're moving from implementation to intent, which is kind of like more of the specification. We're moving from delivering things to more solution discovery because now we're dealing more with finding the right solution, and then it becomes an implementation. We move from dealing with documentation to dealing with knowledge. Hopefully, we can stop micromanaging the chat and so on, and it becomes more of a self-learning thing. And we don't want to have blind automation as run away and then come back in 2 days. But we need to have a way of guiding it and understanding this, how it goes. I think that's it for the talk. If you like this talk, connect on LinkedIn. I'll happily share the slides. Most of my talks are on my YouTube channel if you're interested. And this is the moment where you get your phones out. Thank you very much.